Good afternoon, everyone. So today we are here for a live session for the course Thermal Processing of Foods. So if you have joined, you can post your queries here in the chat box. So meantime, I had seen few queries regarding the problems given in your assignments. So I'll try them solving in this live session. So whenever you joined, if you have some questions, you can post it in the chat. So meantime, we will solve the assignment 3, where you have given maximum problems, and assignment 2 and 1 also you had a few problems that I'll try solving them. Okay, so now we are starting with the questions whatever given in assignment 3. We will go on solving assignment 3 problems. In the first problem, it is given there are two microorganisms X and Y, and for them the D value is given. For X it is 1.2 minute, for Y it is 0.48 minute. Right? And then it is said that the food suspension has 10 to the power of 9 spores initially, so which if you closely follow the class, it is a N0, initial microbial count. And then this D value is given for temperature 121.1 degree centigrade. And then it was asked to find the heating time, which is in minutes, which is needed to obtain the probability of spoilage, which is 1 upon 100. So that means one survivor for 100 microorganisms, right? So it is nothing but a final microbial count. So this is given. So you can take it as a 10 to the power of minus 2, 1 upon 100, 10 to the power of minus 2. So we're asked to find T. The formula is D at the given temperature 121.1 degree centigrade, and then log of N0 upon N. So this is initial microbes, how many spores you have, then after the heat treatment, how much is the final survival. So for this, for both the level, right? If for microorganism X, microorganism Y, the initial and final counts are same, but their D value is different. So if you want to calculate for X, X is 1.2 log of N0 is 10 to the power of 9, 10 to the power of minus 2. So this becomes 1.2 log of 10 to the power of 11, or 9 plus 2, 11. So log 10 goes, so 11 into 1.2. Right? This is for X. For Y, similarly, so you get 0.48 into 11. So obviously, you know, this value is higher than this value. So you need to heat to this particular minute, right, for reaching the final microbial count of N, right? Because if you choose this particular time, then there would be maximum survivor for microorganism X. So whatever is the time, maximum time, that you have to allow for heating so that this process is done, right? So this is given so your answer is given as 13.2. Right, the next question is given the equivalent F value. Second question, equivalent F value needed to inactivate 99.999% of his chain C botulinum, right, at 121.1 degrees centigrade. So to inactivate this much of C bar at 121 degrees centigrade, so you were provided with the F value, which is 0.8 minute, right? And there is some assumption is given, which is F value is calculated using the same Z value as the biological entity represented by D value. So because of this fact, so what you can do is, so F is equal to S into D, right? S is nothing but here survivors, whatever we have just done, right, which is log of N naught upon N, and then you have D value, right? Because this F value is given to you, and you can find out this log N naught upon N from the information given, so that your D value is nothing but F upon S. So from this you will find D value. So how to convert this? So it is said that 99.999%. So this is, you divide it by 100. So whatever you value you get, that 1 minus this particular value is nothing but your number of survivors. So this comes under around 10 to the power of minus 5. So that means what? So your survivors are,
I have not received the writing. I have not received. Can I stop sharing? Or?
yeah, okay. So so this means that you have got 99.999 inactivated, got inactivated, that is percentage. So you convert that into number of survivors, which comes around as 10 to the power of minus 5. So that means 1 upon 10 to the power of 5. So if you had taken initial spores of 10 to the power of 5, then you will find 1 survivor, right? So your initial count, this log N naught is 10 to the power of 5. If then finally 1 survivor remains, right? So log 10 to the power of 5, log 10 goes cancel. So you have got 5. So the survivor is 5, and F value is given as 0.8. So 0.8 upon 5, so which comes around whatever the value given in the problem, which is 0.16. So this is the another problem, which has in this problem where deactivation is given in terms of percentage, you convert them in terms of survivors, so which comes around 5, and then you the survivors gets multiplied with D, that gives you process value. But in this problem, process value and survivor information is given, you're supposed to find out D value. Okay. And then, so these two are separate problems. The next problem comes with the common data, and you're supposed to answer next 3 questions using the common data, right? So if you followed the lecture, then you might have seen something called holding tube, right? So here you maintain the pasteurization temperature at a particular time, right? For example, it is a T1 temperature at a small T1 time, then you maintain the temperature and time in this holding tube. This problem is related to that, right? It is said that a fluid product is to be pasteurized in a continuous system that heats the food to 77 degrees centigrade, followed by a holding in a 4 centimeter diameter. So the diameter of the pipe is given as 4 centimeter sanitary pipe, from which it leaves at 73 degree. So when it comes out of this tube, it is 73 degrees centigrade. And the process is given 5D thermal reduction. So F we just have seen, right? Survivors, which are 5, and then D value 5D, that is also given. And then D value of microorganism is given, that is 0.27 minute. And one more thing you always remember, whenever you write something, please be careful with the units. All units should be of same SI units, right? For example, when you are substituting, one should not, one would be in cm, another would be in meter, then you will obviously make mistakes. So please be careful. And then there are certain information is given. Rho is given, which is 1008 kg per meter cube. And then your viscosity is given 7 Cp, which is centipoise. So to convert centipoise into SI unit, right? So you multiply with 10 to the power of -3. So this will be in kg per second. And then you have given the flow rate, which is nothing but volumetric flow rate is given. So which is given as 25 liter per minute. So if you see your tube dimensions are in meters, right? So here also you convert them into meter cube per minute. So 1000 liter is 1 meter cube. So when you convert, multiply and divide by 1000, so what happens is, so this gets converted into meter cube. And also if you see, everything is in minutes, so you can if you want your velocity in meter per second, because that is what is asked in question, average velocity, maximum velocity, you suppose calculate in meter per second. So here it is given minute, so you also multiply with 60. So that means 60 seconds are 1 minute. So you converted and you multiplied this L by 1000. For that you multiply and divide 1000. So this becomes a meter cube. So 25 upon 1000 into 60. If you get this value, then this becomes in meter cube per minute. Right? And then you very well know how to calculate the velocity. Velocity is nothing but volumetric flow rate upon area. Volumetric flow rate you just have done 25 is 25,000 into 60. Area you know 5 by 4 d square. 4 centi 10 to the power of -2 meter. This is diameter. So pi by 4 d square, right? So this is done. So this is area, this is volumetric flow rate. Whatever you get is the average velocity, which is in meter per second. Right? So the answer is 0.33. So you can work it out. And then here we calculate the Reynolds number. Right? For Reynolds number, you have given rho, which is density. Just now I told 1008. And then diameter, which is 4 centimeter. And then you also find out just now velocity average upon mu. Mu also you converted into SI units. As I said, 7 centipoise you have converted into kg per meter second. So that value is there. So if you substitute here and then get your Reynolds number is coming around approximately 1900. If your Reynolds number falls under transition or laminar region, you can simply calculate your Vmax as a 2 into V average. So this information is also there in the lecture. So by that way, you multiply with this by 2 and then you get as a 0.66 meter second. Okay. And this is velocity average, that is one question. Then finding out maximum velocity, that is another question. Your next question is nothing but finding out the L, length. Right? So we very much know if you want to find out the T, which is nothing but a time for heating. So which is nothing but L upon V, right? So L is in meter, velocity is meter per second. So what we wanted here is L, which is nothing but T into V. So in this V, we have got two velocity. One is maximum velocity, another one is average velocity. So when to be substituted what, right? If you want to calculate T average, if you want to calculate V average, then if you are using V average, then T average should be used, and then length is whatever you are getting as a using V average value. But if you want to use your maximum velocity, then T is nothing but a minimum time required, right? Why it is so? If you, browse through your lecture, somewhere it is said that when you are following certain assumptions like laminar flow, Newtonian fluid, and then incompressible flow, etc., with certain assumptions, when the fluid is flowing through the circular tube, it follows the parabolic velocity profile. That means the center particle reaches very fast. So this take very minimal time, and the center velocity is nothing but a maximum velocity. And also, if you remember, when we discussed about the sterilization, we said that the center particle is nothing but a slowest heating zone, right? So that particle only reaches very fast with the minimum T. So when you use maximum velocity, whatever the time you are getting is a minimum time. So accordingly, you calculate the length of that pipe, right? Whether you need to use average, if it is asked average based on average velocity, you use based on average velocity, or if you are using V max, then it should be T minimum temperature. So L you have, and then your time is given, which is 0.27. Remember that is given in minute, but we are working with second, so it is 60. And then you have got maximum velocity is 0.66. So your length would be coming as 10.7 meter. Okay, so that is a set of 3 questions. For that, common data is given. And then the next part is again set of questions. Common data is given for set of questions. So there T1, T2, T3 is given, 320 Kelvin, 323 Kelvin, and then 330 Kelvin. For that, rate constant is given. K1, K2, K3 is given, which is 0.02, 0.05, and then 0.18. Right, all are in minute power -1. So for this, these are based on formulas only. So you don't need to use any concepts, etc. So for finding out activation energy, it is said that K1, K2 upon K1, which is nothing but a rate constant. Okay, so these are rate constants. So K2 upon K1 is nothing but e power minus EA upon R, 1 upon T2 minus 1 upon T1. Right? So if you take these two temperature, any set you can take, there is no hard and fast rule. So T1, T2 you can take, or T2, T3 you can take, right? So whatever two temperatures corresponding to rate constants. So I have, we can take the first two set. So K2 upon K1 is minus EA upon R. This is an exponential function, 1 upon T2, 1 upon T1. So let me check whether R is given. Yes, given. So R is given as 1.987 calories per gram of Kelvin. Right. So you are working with Kelvin. So substitute all temperatures in Kelvin. R is 1.987 and K2, K1 is 0.05, 0.02. T2 is 323. This is 320. Then from this you can find out EA, which comes under which comes as calories per gram. Right. Same way, the next two which are asked is Z value and Q10 value. So you can follow the concepts and then derivation in your the lecture material. So here I'm just telling you how to calculate. So for for Z value, you have many formulas. One is 10 ln 10 upon ln Q10. Right? For this, if you know Q10, you can directly calculate, or if you don't know, because this is asked as a second question, this is third question. When you come to this question, you may not be knowing Q10. So for that, you can use 2.303 or T1, T2 upon E. E you have just obtained, T1 you know, T2 you know, R you know. From this, you can calculate Z. Once you calculate Z, then your Q10 value is very straightforward. Ln of Q10, which is equivalent to 10E upon R T1 T2. So E you know, R you know, T1 you know, T2 you know. Find out ln Q10. Please don't forget to convert that into E power ln Q10. Right? Then only you will obtain Q10 value. You were asked to find out Q10 value directly. So these are all the sums whatever we have asked in assignment 3. Anyway, solution would be provided later, but some of you asked me to solve in the live session. And for assignment 1 and 2, it is very straightforward question. Assignment 1, what we asked is just to practice, that is QMCP del T. So if you want to calculate the heat given, then you will use mass flow rate, m dot, and then Cp is specific heat, and then temperature difference. So in that it was given heat exchanger is cooled from 21 to 8, right? So the temperature difference is 21 minus 8, and then milk specific heat is given as a 3.9 kilojoules per kg Kelvin. So this temperature difference, whether you use degree centigrade or K, that doesn't matter. So this is the value. This comes as a K. And then they have given mass flow rate as a 4000 kg per hour. Right? Kelvin get cancelled, kg get cancelled. What you get is kilojoules per hour cube. Right? So for the milk side, you have given mass flow rate, you have given specific heat, you have given temperature difference. So you calculate what is Q. So what it is said, so this is exchanged to the water, right? So using water, this temperature is brought down to 8 degrees. So what is the water side we are using? Water side, your Cp is given, right, which is nothing but 4.2 kilojoules per kg Kelvin, and the temperature difference is also given, right? So water enters at 2 and leaves at 6, so 6 minus 2. So you have got your del T. You are asked to find what should be the mass flow rate of the water. So you have already got Q. So this has to be exchanged between milk and water. So Q is same for milk and water. So you have this Q here. This is the value you know, and Cp value you know, temperature difference between inlet and outlet of the water you know. So from this you find out what should be your mass flow rate of the water. This is assignment 1 we asked. Right. So then next assignment 2, there is a straightforward question. Right. One question says the D value for the most heat resistant microorganism, which is Clostridium botulinum. So it is around 0.2 minute. Now another question, it is asked to find out F0 value of generally accepted as a realistic minimum botulinum thermal process, because we said that CBOT is nothing but a most heat resistant. We are supposed to find out F0 value. F0 value is calculated at 121 degree centigrade only. So just now we have seen F0 is nothing but a SD0 or D at 121 degree. So S is nothing but for sterilization. We learned that it is a what is that? 12D process. So 12 into 0.2. For sterilization, it is 12D. For pasteurization, it is 5D. Right? So 12D process 12 into 0.2. So this comes around 2.4. So we rounded it off, and the next gross value is given as 3. Right? Sometimes it happens if you are having, for example, M, CP, del T, and upon something, right? So just now we had seen, right? So this is you were asked to find mass flow rate of the water. So if I am finding it directly, what I'll do, mass flow rate of milk, mass flow rate Cp del T of milk divided by Cp del T of water. Right? This is one step calculation. But sometimes what you do is you first calculate Q and then come and substitute here. Sorry. And then divide by Cp once and divide by del T once. Sometimes you do 4 or 5 steps. So because of that, there will be a slight change in your answer. For example, answer is given 12.7. You might get 12.2 or 23 kind of, right? Based on how many digits you take and all. So you just look for what is the closest answer. We will ensure to give the answers with the proper decimal places, but however, you look for that one. And also this is not related to decimal places, because in the industry it is always good to go more than this, right? 2.4 minute means, so they will always go factor of safety. That is why it is given as 3 minutes. But in general, when you are solving problems, you just look for what is the closest value given as a MCQ. Okay, so for all sorry, 3 assignments, whatever problems given, I have discussed here. So if you still have any queries, you can post it. Okay, so I have done all the assignment problems. If you have any queries, please ask. Then you can put it in chat box. You can ask directly, or you can unmute and ask also. I'll wait for another 5 minutes. So if you want to ask, you can unmute and ask, or you can put it in chat box. I have answered all your queries, whatever asked in the discussion forum. You can check if you had asked over there. And the common queries, solving the problems which are given in the
Last question.
Okay, since we haven't received any queries, we would like to end the live session. However, you can post your queries in discussion forum, and my email ID is also available. You can mail me also. Okay, thank you so much.